Good evening, everyone, friends. Let me share my screen. Welcome back to our 30 days program from Python to AI. Right? So we'll quickly recap what we have covered so far. Then we'll start with a new topic. We'll start a new topic today. Right. So as part of this program, you know, we have initially completed Python module. Under Python module, we understood the basics, the foundations, right? So this module was being done. Then the next module in which we started understanding EDA. What is this EDA? Exploratory data analysis. But before I talk about EDA, we got uh, we got familiar with the project management methodology called as CRISP MLQ, Cross Industry Standard Process for Machine Learning with Quality Assurance, right? So it's a project management methodology, and this CRISP MLQ in total has 6 phases, right, friends? So as part of these 6 phases, we understood data, business, and data understanding. Then the second phase is data preparation. Under data preparation, we understood EDA, right? So we understood EDA, how we have to understand the data characteristics and all. Then under EDA, we understood the moments, how to visualize the raw data, and again we have also understood how we are supposed to perform data cleaning, data cleansing. And in total, data cleansing has 9 steps. All the 9 steps were being discussed, and we have took a same data set for performing all the 9 steps. Cars. Yesterday, we discussed the transformations. Transformations is part of data cleansing step. What is the purpose of transformations, friend? Why should we do transformations? Why it is mandatory, or what exactly do you mean by transformations? Use the chat and post your answers. Come on, friends. To represent the data, why do we do transformations? See, if you have data which is non-normal, okay, in order to convert this non-normal data to normal, we do transformations. And which plot tells about the normality of the data? Which plot did we visualize yesterday, friends? What is the plot that we have visualized to check the normality of the data? Good. In order to modify the non-normal data to normal data, we do transformations. Perfect. Which plot? Yep, good. It is nothing but QQ plot. What does QQ represent? What is the meaning of QQ? Yes, it is QQ plot. Good. QQ represents quantile plot. So on the x-axis you'll have quantiles, on the y-axis also you'll have quantiles. But both are they both same? No. On x-axis, the quantiles that you take are nothing but the z values. What is z and all we'll discuss later. Okay, and on y-axis we'll have sample quantiles, nothing but the data friends. This is the data on which we'll take it on y-axis, and we calculate the z values from the data and we'll plot it on x-axis. And if the line, if it is passing through the majority of these data points, the scatter, okay, then we say that the plot is normal, the data is normal, and we need not perform any kind of transformations. What if this red line, the line that we have in this QQ plot, if it is not passing through majority of the points, we do transformations. Why? It tells us that the data is non-normal and we have to convert it to normal. But is it required for all the data? No. As we discussed, some of the machine learning algorithms, ML algorithms, they assume or they are built on top of normally distributed data. And if you try to build your algorithm, if you try to build your model on non-normal data, you may get the results very bad. You'll get very bad results. So that is the reason we convert this normally non-normal data to normal data by applying transformations. Okay, so tell me uh, some transformations that we have applied yesterday. Manual transformations. I don't want to automate. First, tell me the manual transformations that we have done. Uh, mm, yes, square transformation. Then log transformation. What else we have, friends? Cube transformation. Then exponential transformation, reciprocal transformation, cube root, square root, all of these are nothing but different transformations that are available. By just looking at this data, we cannot tell which transformation works well, right? So this is like an experiment that we do. Okay, so but this is time consuming, right? So in order to automate the transformation process, we also understood uh, two types of automated transformations. What are they, friends? What are they? Box Cox and Yo Johnson. Yo Johnson, right? So what makes the difference between Box Cox and Yo Johnson? Both of them are part of automated transformations. That's okay. Both of them they work in the similar manner, but there are some there is a you know difference between Box Cox and Yo Johnson. What is that? Hmm? What is the challenge that Box Cox has? Did I tell that? Box Cox for normal distribution. Good. Yo Johnson technique, okay, can be applied on all different types of values. But when it comes to Box Cox, it has a challenge. What is the challenge? Box Cox cannot be applied for negative values. Good. That means in your data, okay, if there are some negative values, okay, on this particular data, you cannot apply box cogs as part of transformations. You have to go with Yo Johnson only. Okay, so this is a challenge with respect to box cogs transformation. While Yo Johnson, it overcomes the challenge of box cogs. That makes the difference. Right. So, what are the packages that we use for box cogs and Yo Johnson? Any idea? I know that's a bit difficult thing to remember the modules, but do you remember the libraries that were used for Boxcox and Yo Johnson? At least good. Feature engine for Yo Johnson. For boxcards, not it's not sklearn, but for boxcards we used scipy.stats subpackage. Scipy is the package and stats is the subpackage. Right? So inside this stats subpackage we have boxcards available as a function, and you can directly go and perform boxcards transformation. In the same way, feature underscore engine is the package, and within this package there is a package called transformations. Okay, so under this subpackage we have Yo Johnson transformer as the function. We can use it. So it's very clear, right? Transformations are applied for modifying non-normal data or for converting non-normal data to normal data. Good. Now, what is the next step that we have discussed? Feature scaling, also called as feature shrinking. Right? So, what is this feature scaling or feature shrinking? Come on, friends. See, if you together work on all these 9 steps on a data set, on a structured data set, okay, that becomes a project. That's why I'm asking you, I'm revising, I'm taking enough time to revise all these topics. Yes, all the features, all the columns that are part of the data should be scaled. The reason is if you don't scale the features, if you don't scale or if you don't shrink the features, the columns that are part of the data, the model gets biased towards the column which has the higher values. So, in order to overcome this problem, we'll perform feature scaling. What are the different types we have under feature scaling? It's not exactly compression. Compression actually changes the meaning, but still okay. What are the different techniques we have under feature scaling? How feature scaling can be done? Standardization, good. Normalization, perfect. And robust scalar, robust scaling, good friends. Right? So standardization, normalization, and robust scaling are the three different techniques that are part of feature scaling. So I'll start with the first one, standardization. So what is the formula that standardization, technique uses? What formula it uses? What is the formula? Not exactly, but still, give a try. X minus mean by sigma. X minus mu by sigma. What does X represent? X takes the value of that particular column or particular data. Okay, mu is nothing but the mean of that particular column. Sigma is nothing but the standard deviation of that particular column. Okay, so what will be the output of standardization with respect to all the columns? What can you you know interpret as the result with respect to standardization? Mean of all the columns will be 0. Standard deviation will be 1. Okay, so mean will be 0, standard deviation will be 1. Right? So this will be the output of standardization. Let us talk about normalization. What is the formula that normalization uses? for performing feature scale. What is the formula, friends? Make it fast. X minus minimum by max minus minimum. Right? So this is nothing but x minus minimum by range. Min max scalar is the function that is used. I'm asking the formula x minus minimum by range, nothing but maximum minus minimum. So when we work on normalization, what will be the output, friends? What will be the output of normalization? What will be the output of min max scalar? Excuse me. Minimum of all the columns becomes 0. Maximum of all the columns become 1. So what you are doing, you are scaling all the features between 0 and 1. For all the columns of the data, the maximum value will be 1 and the minimum value will be 0. What about the rest of the values? They lie between 0 and 1. That's it. So if you do hands-on, you can interpret all these things. Okay, so yesterday I have shown you enough thing, but still, if you do hands-on only, you can interpret more, friends. Okay, so what is the last technique of feature scaling? Robust scalar, robust scaling. What is the formula? What formula it uses? What formula it uses to perform scaling? X minus median by IQR. Good. Okay, what will be the output of robust scalar? Median of all the columns becomes 0, IQR becomes 1. Okay, so this will be the output of robust scaling. Then, when is robust scaling used? When is robust scaling used? On the data which has outliers. Am I right? Good. If the data has outliers, yes. On such type of data, we perform robust scaling. When is normalization used? Normalization is used when you want to bring all the features to a particular range. See, if you have 10 features, 10 columns, and if you want to bring all these 10 columns into a particular range, say 0 to 1, then go with normalization. Because that is the output, right? See, the minimum value will be 0, maximum value will be 1. So you are bringing all the features to a particular scale. When is standardization used? Standardization is used when you want to alter the distribution. What is these two things representing? Obviously, they are representing the distribution of the data. So, initially, you will have some mean value, some assume 100. Then you will have some standard deviation. Okay, so this is changing or it's getting transformed to 0 and 1. So Obviously what you are doing, what's happening, standardization is actually used when you want to alter the distribution of the data, right? So yes, obviously it is converting the data to normal distribution. Good. Okay, this is what we have understood yesterday, and that marked the end of data cleaning. So I hope it's clear. Okay, let us not drag much. Now let us enter the next phase of CRISP MLQ. What are the phases of CRISP MLQ, friends? The first phase is business and data understanding. Second phase is data preparation. What is the third phase? Third phase. Third phase is nothing but model building. Am I right? What is the fourth phase? Good. Business and data understanding. Then data preparation. Third phase is nothing but you are going to build a model building. Fourth phase will be model evaluation. The model that you have built should be evaluated. How can you deploy it without evaluation? Right? So be careful. Then comes the fifth phase, which is nothing but model deployment. If the model is perfect, it is working, it's giving good results, then we have to deploy it. Yes. What is the sixth phase of CRISP MLQ? Deployment is already done. It's not feedback, maintenance. Maintenance. But before maintenance, we continuously monitor, monitoring and maintenance. Okay, so we'll start with this topic today. As we can understand, we are going to introduce to the new concepts under machine learning. So in order to build a model, we have to learn ML algorithms. Okay, since we have confined this particular program to 30 days, we'll be learning the two top algorithms of machine learning. Okay, so initially we'll discuss what is machine learning, then what is the types that are available in machine learning, and how the model gets built in the back end. Everything we are going to discuss today. So pay attention, friends, because this today is going to make a remarkable journey in your life. Probably, if you are interested towards moving your career towards machine learning or artificial intelligence, uh, this particular session will help you a lot. The reason is, before understanding or before building a model, you have to know what is machine learning, because machine learning algorithms are only used to build a model, right? So these machine learning algorithms, there are how many algorithms are available in machine learning? There are n. And takes, there are plenty, thousands of algorithms are available under machine learning, but still, no one learns all these thousands of machine learning algorithms. So in real world, whoever works in the real world, they just learn only probably 20 to 30 important algorithms under machine learning. So we'll be learning the top two machine learning algorithms as part of this program. But in order to understand those two algorithms, you have to understand the class of today. Today's class is very important, so pay attention. Okay. Then, for each of these two algorithms that we are going to learn, we'll also discuss the evaluation techniques. probably in the next week. Then for one of these two algorithms, we'll do an end-to-end project. End-to-end. See, listen properly. End-to-end in the sense, we'll be covering all the 5 phases of crisp MLQ till deployment, because it's not possible to work on monitoring and maintenance. Uh, okay, so what we have done is particular algorithm called KNN. For KNN, we are actually planning to discuss an end-to-end project that will be on the last few days. Probably the last 2 days, we'll have a KNN use case, an end-to-end project on KNN. Okay, how a model has to be built, how it will be evaluated, then how it will be deployed, everything we are going to learn. Okay, so yeah, everything we'll understand, pay attention, and moreover, I need your patience. We'll discuss the list of algorithms and all we'll discuss in today's class. Right, so we'll quickly understand what is this machine learning and jump into the types. Okay, so as we all are aware of artificial intelligence, AI, right? So this machine learning is a subset of AI. Don't assume this is a completely different topic, friends. So if you have AI, if this is AI, machine learning is a subset of AI. So what is exactly happening with respect to machine learning is, you know, we are actually training some systems using this machine learning algorithms. We are training some systems, and this system start understanding, okay, understanding the data, and it gets trained and it starts taking decisions. Okay, so how it will be trained, everything we are going to understand. Then, so in the back end, what exactly happens is it tries to capture the patterns available in the data. Using that, y is equals to f of x equation, it tries to understand the pattern, hidden pattern which is available in the data. It tries to understand or capture that pattern, and then if this particular model got predicted, if this particular model got built, we can use this model on the new data, and this model helps us to go for predictions. So if you pass only the inputs, it gives you the output. Is that possible? Yes, I'll show you everything. So that's what machine learning and artificial intelligence, they're booming in the current market. They're paying very huge for these experts, machine learning engineer, data scientist, and artificial AI engineer. Okay, all of these fall into the same category, but depending on the data they use, they give the designation. Okay, so again, when I speak about data or when I talk about the data, I am talking about the characteristics. So go back to that topic, friends. Structured, unstructured. Okay, so all these come into the picture. Right. So this is a quick introduction about machine learning. It is nothing but a subset of AI, okay, which tries to identify the patterns, the underlying patterns in the data, which get trained. Okay, in the back end, it forms an equation in this fashion, and this particular equation helps us to go for predictions when we pass inputs. So the best example is predicting stocks. I don't know how many of you are actually investing in stock market, but if you try to understand a equation, if you try to understand machine learning concepts, you can also build a equation on your own. Nothing but a model. You can build a model on your own and go for predictions. And this will tell you whether you have to invest or not. But trust me, friends, even not all models give you the best results. Some might give you the best one, but first of all, you should have the data of that particular stock. Okay, so this is completely a different scenario, but in general, each and every domain, machine learning or AI is being used for predictions, for making decisions in today's market. Okay, so let us not waste our time. We'll go to the slide next. So, what are the core concepts that we have under machine learning? Machine learning is broadly classified into three types. One is supervised, the next one is unsupervised, and the third one is reinforcement learning. Okay, so supervised, unsupervised, and reinforcement learning are the types that we have under machine learning. Right? So, what is supervised learning? Supervised learning is nothing but the model learns from the label data. What is label data? What is label data? Data in which you have both inputs and output. Such kind of data is called label data. Label represents, the Y column. So on label data, we can use supervised learning. We can build a supervised model. Some of the commonly used supervised learning algorithms are over here: linear regression, decision tree, SVM, KNN, naive Bayes, then what else? Logistic regression. So all are these are part of supervised learning, and supervised learning models, they learn only from a labeled data. Labeled data represents the data in which there is output. Actually, what do you mean by output? Simple, friends. If you ask me an example, I take the data of your class. Okay, so in your class, assume there are 100 students. Okay, I'll take the data of all these 100 students in an Excel sheet or in a structured fashion, in which I have the name of the student, their probably gender, how much time they spent on social media, okay, then their preparation time. Okay, so all these columns, I'll get all these columns filled with respect to each and every student, and finally their marks. Okay, and the last column is whether they'll pass or fail in the upcoming exam. So this is my output. Okay, by taking all these inputs, what am I predicting? I'll predict whether the student will pass or fail. Okay, so is this a label data? Yes, because I have Y column. Since I have Y column, I have to go with supervised learning algorithms. Then we have the second version. It is unsupervised learning, and unsupervised learning models, they are generally built on top of unlabeled data. That means the data in which there is no Y, only X. What does that mean? Only inputs, no output. Yes, can we have such kind of data? Yeah, yes, friends. We will have such kind of data where there is no Y column, the output column. Okay, Akhil, again, can you give an example? I'll take the same data, I'll remove this column. I'll remove this column. So I'll assume all these as inputs, and instead of predicting, what if I want to group you guys based on your performance? I'll group you guys into three groups. Am I predicting anything? No. I'm just grouping you based on your characteristics. Okay, so the widely used, the best algorithm that we have is clustering, nothing but grouping. And one of the famous algorithm that we have under clustering is k-means. So this k-means algorithm will be our next topic, and we are going to learn k-means, okay, as part of this program. So as I have discussed earlier, one from unsupervised, one from supervised. So under unsupervised, we are going to learn k-means algorithm, which is part of clustering. Clustering is nothing but grouping friends. And in unsupervised learning, algorithms, the model will be built on unlabeled data, the data in which there is no output. And under unsupervised learning, we are going to learn KNN, K nearest neighbors algorithm, where the model will be built on top of labeled data. So there will be output column in our data. So we'll discuss. And what are the other common algorithms that we have under unsupervised learning? We have clustering, we have dimensionality reduction, we have recommendation engine, we have you know mm, association rules, network analytics. All these are part of unsupervised learning, and it's impossible to talk about or learn all these things within few days. But the widely used algorithms will be learned. Right? So let us not deviate from the class. And where do we generally find the applications of unsupervised learning is customer segmentation. So what is the use of customer segmentation? Is there any, are we getting any, are we benefited at the end by just performing customer segmentation? Yes, friends. You take any domain, they do customer segmentation. Why? They target customers based on their segments. Oh, is that real? Yes. Take banking sector. Okay, so depending on your CIBIL score, they may do customer segmentation. Okay, or depending on the transactions, they may do segmentation. Okay, and based on your probably your performance, they'll be making you segments, and with respect to your segments, they'll target you. If you have more CIBIL score, okay, if you have more CIBIL score, the opportunity of getting loans will be very high. Even though if you don't want a loan, the people from various banks, they'll call you. You'll get a call and they'll ask you to take a loan where they are ready to give a loan with very minimal interest, very small interest also. But in the same way, assume I don't have proper CIBIL score and I fall into the third category. Okay, they don't even, they are not ready to call me first of all because of my CIBIL score or depending on my transactions. There might be XYZ factors. Okay, so who is actually doing this segmentation? The segmentation will be done based on the data. If you don't have the data, obviously we cannot segment. But once if you have the data, you have to use some unsupervised algorithm like k-means, agglomerative clustering, or DB scan clustering. Okay, there are n. I told you right. Under machine learning, there are n different types of algorithms. Only under clustering, I have probably 10, 15 algorithms. Many friends. Agglomerative, k-means, DB scan, optics. What else? Chevilian, okay, K-medioids, K-modes, okay, fuzzy C means there are n number, but no one will learn all these algorithms. Okay, what are the widely used clustering algorithms? Widely used clustering algorithms are K-means, agglomerative clustering, DB scan. Okay, let us try these three on the data first. If they are giving good results, proceed. If you are not getting good results, then you have to work on rest of the algorithms. That's how in general the real world practice be like. Okay, so the widely used algorithm k-means will be understood in the next week probably. We'll start with k-means, the first algorithm, and next to it we'll go with knn. Okay, so the last type is reinforcement learning. Reinforcement learning is generally it it gets trained, or the model gets learned based on its feedback, the rewards and penalties. Okay, and this is generally observed in case of robotics. The best example. If you take a robot based on the feedback that it gets, the reward or the penalty that it gets trained. Okay, so as we are running out of time, we don't have any sessions on reinforcement learning, but probably in the next program we'll look out for a use case with respect to reinforcement learning as well. Right. Now let us, out of again supervised and unsupervised, supervised is very widely used in real world. Okay, so supervised learning is very widely used, and why it is widely used? Because these algorithms help us to predict. So that is the reason we will be called as data scientist. And in general, probably you may have heard this or not. I'm not sure, but just as a statement, I'm giving this. India is very widely famous for Baba's friends. Am I right? Who is a Baba? The one who is a fortune teller, right? Who says that we'll be winning this ICC Champions Trophy, which is going to happen in the next month, or some XYZ thing will happen in the next 2 years. So these are some kind of predictions that they do. And that's again different story. But India is widely famous for Babas who generally do predictions. But we are also doing predictions. Are we again Babas? No. We are not similar to these Babas. We are the real Babas. The reason is we have an explanation for our prediction, but they don't have any explanation for their prediction. They'll just tell if the thing happens, if that particular thing happens, they'll get the fame. But in our case, it's not like that. We have an explanation for our prediction, but they don't have any explanation. They just, predict. Right? So this case is different. And in general, in real world also, supervised learning algorithms are widely used. The reason is it helps us to predict, it helps us to do predictions on the new data. Okay, so how are the predictions done? Again, what are the different types of supervised learning algorithms we have? Everything we'll understand. Okay, so let me just proceed. Yeah, so the supervised learning algorithms are actually built on top of label data. What is the label data? Label data is the data that has both inputs and output. Okay, here are some examples. Predicting house prices. House price is Y output based on size, location, number of rooms. Okay, so all these comes into the picture and they act as inputs. A very widely used example for label data, that is predicting house prices. For in this case, we are supposed to use supervised learning algorithms only because it is labeled data, right? So obviously we have to go and use supervised learning algorithms. But what exactly are we going to create? We will create an equation, friends. Y is equals to f of x. Y represents the output and x represents our input. F is representing a function of inputs. So in the back end, an equation will be created. When the model gets trained, okay, so it tries to understand the pattern which is lying in the data and an equation gets created in the back end. So if I take the new data, if I'm working on the new data, I just pass these inputs. So obviously I get Y. What does that mean? I get the prediction for these inputs. In that way, supervised learning algorithms helps us to predict on the new data. But what is the learning process? What is the learning journey? How does the learning process happen? The learning process happen in such a way that it adjusts the parameters. What are the parameters? These are the parameters. It adjusts these parameters or the coefficients, okay, using the data to minimize the difference between predicted and actual. What does this mean? This mean that, for example, I have my bike. This is the data. Okay, so I started building a model. I'll pass each row to the model. Okay, so model takes each and every row in sequence and it gets trained in the backend. So obviously, when it gets trained, we have to if it got trained, we should also test it on the new data. Yes. So when I test it on the new data, I get y cap, the prediction. Okay, assume that I have tested on the same data without passing by. Okay, so I'll get y cap, the prediction. So the difference between these two should be reduced as we keep on training the model. The difference between the predicted and the actual should get reduced, minimized. In that way, in such process, the learning journey happens, and when the predictions are very close, we can say that the model is performing well on the data. What if the predictions are very far? Obviously, it is not actually performing well. You have to tune the model. We tune it to get the better results, right? So we discuss the types of supervised learning. Okay, so supervised learning is broadly classified into two types. One is called as regression, and the next one is called as classification. Okay, supervised is again broken into two types: regression, classification. Okay, so classification, the name itself, it is telling us classification algorithms are used to predict discrete categories or classes. That means you will have y column, right? In this y column, if you have discrete data, what does discrete data mean? Data which has fixed set of values. For example, in my y column, I have classes like this: pass, fail, fail, pass. So these are fixed. I can't get the third option, right? So if you have discrete values, discrete categories in your y column, then classification algorithms will be used. So you can classify pass and fail. This is one class and this is the other class. Okay, but there is regression also. Regression is used for you know predicting continuous data. What is the meaning of continuous data? Let us go for an example. Predicting house price. Will the house price be fixed? Like we have it in this case, classification case? No. House prices vary depending on the inputs. Yes. So obviously, if you have a data in which the y column contains continuous values, like predicting stock price 1.1, 10.5. So these are some kind of continuous values, and I'm supposed to use only regression algorithms, friends. Classification doesn't hold properly. Okay, classification algorithms are used to predict discrete values. If you have discrete values in your y column, then go with classification algorithms. Excuse me. And in the same way, if you have continuous values in your y column, go with regression. Okay, so I'll take an example, but before that, yes. Now This is probably the coming 10 to 15 minutes is very important because we are going to discuss the primer of ML. I hope it's very clear. Machine learning is broadly classified into three types: unsupervised, then supervised, and finally reinforcement learning. Okay, so supervised is again classified into two types. Okay, so when should we use unsupervised algorithms? When we are working on unlabeled data, y is absent. When is supervised algorithms are used, y is present. Okay, so this is on unlabeled data and this is on labeled data. And reinforcement learning is completely, it's on a different data set. Let us not go into this. Supervised learning is again broadly classified into two types: regression and classification. Okay, so when should we use regression algorithms? So this is on continuous values. If you have, in your y column, if you have continuous values, go with regression algorithm. And if you have discrete values under y column, you go with classification values. Clear? Yes. Now we will understand how a supervised algorithm model, using a supervised algorithm, learning algorithm, how a model gets built, what is the process, what is the journey we are going to understand. So please focus, right? So I'll take a small data set first of all. Assume I have a data set in this fashion. There are four inputs and one output. No, friends, it's not the relationship. Okay, so regression algorithms are used uh, to predict continuous data. If you have continuous data available in your labeled data, okay, then go with the regression algorithms. It's not relationship. Obviously, they talk about relationship because you are going to get the relation between x and y, but still that might not be a proper sentence. But yeah, okay. So we are going to understand how a supervised, model algorithm model gets built from end to end. Please focus. Uh, Not random. What do you mean by random? No, it's not random. Anyways, 1 minute. I'll get back to your questions at the last. Let me complete this. So, I'm taking a labeled data. The size of this labeled data is, say, 100 by 5. How many rows are available in this data set, friends? How many rows are available in this data? Please use the chart. Yes, it is 100 rows. 100 by 5 rows by columns. 100 rows. Okay. So 100 rows and 5 columns. Clear? How many inputs do I have in this data? My question is, how many inputs do we have in this data? Good. 4. How many outputs? One output. 4 inputs, one output. Or let me keep like this. Any question so far? No, right? 100 rows, 5 columns. Out of 5 columns, you know, we have we have 4 inputs and one output. Right. Now, let us chart what is the actual process that will be followed with respect to any supervised learning algorithm. See, if you understand the next 10-15 minutes, okay, you will understand what will be the journey of all supervised algorithms. All the supervised learning algorithms, they follow the same pattern, the same structure will be followed. So pay attention. So there are 100 rows and 5 columns in my data set. What I'm going to do is, initially, the original data that I have, I'll make it into two parts. I'll make it into two parts. The first part is train, and the second part is test. Again, the question comes here. Akhil, why are we separating or why are we partitioning the data into two parts? Let me tell you, my friend. The answer is, you know, you have a data. This is your data that was shared by the client, which is of 100 rows and 5 columns. You know, you have to build a model. Am I right? You have to build a supervised model, supervised learning model. On top of this data, you have to train it, and that particular model should also be used for doing predictions on the new data, right? Yes. But the question is, assume that these 100 rows and 5 columns are used for training of the model. Okay, the entire data that you have, if it was used for training, and how do you test it? What do you mean by testing actually? Testing is nothing but, I told you right, post completing model building phase, we have model evaluation. Yeah, I remember the fourth phase of CRISPR-MQ, right? Yeah, yes. So this particular model evaluation has to be done. You are building, training done. The model gets built, but don't you check its performance? What if you don't check its performance, and what if you deploy it? The model may or may not work on the new data. A small example, I'll relate this example to our real time friends. Okay, so all of us came from student life. Yes, everyone should have experienced this. So, under student life, let us go back to probably when we are a kid. Okay, so when we are a student, what do? We initially get trained on the classes that the lecturers teach us. Yes, the teachers, the professors, the lecturers, whomever may be, they initially teach and will get trained. So, will you go directly and write the exam? For example, say if I have a student who is preparing for GATE, okay, I have a student whom I'm supposed to train on GATE, okay, under GATE, let me take DA only, Data Science and Artificial Intelligence paper. So friends, probably might be you are aware of that or not, I don't know. But recently in the year 2024, there was a new paper added to this GATE. GATE has added a new paper that is for data science and artificial intelligence. If you are interested, just go and apply for DA following from this year. Okay, so assume that there is a participant who have enrolled for DA exam under GATE, and I'm supposed to train him. Okay, so I'll train him. I'll teach all the various concepts. Okay, all the algorithms, each and everything. I'll be training the particular student. But will I directly send him to the GATE exam? Will I send him to the GATE exam directly? Will I send him or her to the exam? No. Initially, post training, I have to conduct some kind of testing activities, mock exams, mock, I'll conduct some kind of test with respect to what he or she have trained. On daily basis, I'll train, test him or test her. Once if the student is performing well, then I can probably send him or her to the main exam, so that I can get some enough confidence. Okay, this guy can clear the exam. But without testing, can he or she appear the real exam? They can, but still the confidence, zero. Yes, mock test. That's what. In the same way, if you relate in a similar way to this process of model building, we partition our data that we have. This data is nothing but the historical data, friends. What do you mean by historical data, Akhil? Historical data means the data that I have collected till yesterday. So you are building a model for your client, right? Your client will store the data. Yes, the data that you have, the client stored in the database or cloud, whatever it might be. They give the permission to the data, and that data is nothing but historical data, the data that was collected till yesterday. Okay, so by taking the data, you have to, or we have to, partition it into two parts. One is train, then the next one is test. And it was always, there is a thumb rule that, train data should be greater than test data. Okay, train data should be greater than test data. So why Akhil? I'll tell you. We'll talk about all these things, once if we complete this process. Assume I have, you know, made it into two parts, and train has 70% of the data and test has 30% of the data. Train dataset has 70% of the data and test dataset has 30% of the data. Now, can you tell me what will be the size of train dataset and what will be the size of test dataset? Just give a try, friends. The question is, what will be the size of train and test datasets? So, will it be 70 by 5 and 30 by 5? Yes, obviously. 70 by 5, 30 by 5 will be the shape of train and test data sets respectively. Yes. Okay. So that's what 70%, 30% is nothing but we are taking 70% of this data to train data set, 30% of this data to test data set. Okay. So 70% of the data is nothing but 70 by 5. How many rows I have here? 70 rows. How many columns? 5 columns. How many rows do I have under test data set? 30. How many columns? 5 columns. How many inputs I have under these 5 columns? Under train data set, how many inputs do I have? 4. Good, pay attention. 4. How many outputs? 1. Yes, yes. In the same way, 4 inputs, 1 output. Is it clear? Yes. Now I take this train data set. Okay, I'll take this 70 by 5 and I'll build that equation. This is called as model training. We train the model on the train data set. to build a mathematical equation. Okay, what does training include? Training includes passing both x and y of the trained data set to the model, and in the backend it understands the underlying pattern with respect to this data, and it creates or it forms a equation in this in a similar format, y is equals to f of x. Okay, and once model training is done, we'll take this model and we'll work it on the test data set. Model training is done. That means the model has been, the equation has been generated, it got built. By taking this model, I will go and use this model on test data set. When you try to use this model on test data set, you know, y is equals to f of x. Should I pass both? Should I pass both inputs and output that I have in test data set? No, we have to pass only inputs. So that gives me predictions. I am representing with cap friends. If I pass only inputs, I will get predictions. And I also have y. Now I'll compare this y with y cap, nothing but predictions. Okay, if I get the similar values, whatever I have in the original y, whatever is my actual value, and if my predicted value both are seen, or if they are both close, in that case, model is performing well. Okay, then again I'll go back, I'll do it on the same thing. I'll do it on train data as well, by passing only inputs to this equation, the model. Okay, only inputs will be passed. So again I'll get you know e- predictions. So again I have to compare both of them, y and y cap. What is y here? The y that I have here. Okay, when I compare both of them, again I'll get some kind of accuracy. Here also I'll get some accuracy. This accuracy is called as train accuracy, and the accuracy that we get here is called test accuracy. If train accuracy and test accuracy both are close, or if they are equal, assume if I get 98% on train data and if I get 96% accuracy on test data, that means we have got a right fit model. This is something different. Okay, so right fit model is what our aim is. We have to build a right fit model with the highest possible accuracy. What do you mean by accuracy? Accuracy is nothing but you know pre, giving the results as is, how accurate the results are. Okay, so would you like to build a model which performs only 70% accurate result? No, obviously no. That means in rest of the 30% cases it fails, error. So there is a mathematical equation between accuracy and error, friends. Accuracy plus error will become 100. So if your accuracy is 70%, error will be 30%. So the model has 30% of the chance going wrong, and the model has 70% of the chance going right. So the process is same. What are we doing? Taking the data, partitioning into two types, train and test. Then in train data, taking the train data, I'll take both inputs and output. All the entire data will be taken and it will be used to train the model. Initially, when we are training, you have to pass both x and y. Only then the model understands the underlying patterns, the hidden patterns. Okay, so then this particular equation will be framed. This equation is nothing but the model, and I'll take this model, I'll use it on my data, nothing but the new data. Why it is new data? Because it did not train on the test data set, right? So obviously, you are taking your model to test it on the new data. You are training your student on some XYZ concepts. Again, if you keep or if you conduct the mock interviews on the same questions that you have trained, obviously the student will perform well, right? But if you test him or her on the new or similar kind of questions, how is his or her performance? You have to check. Either the person, either our student learning the concept or student by hearting, mug up. If the student by hearts, only he or she will perform on the trained questions. But if the student understands the concepts, you know, for sure they can now answer any kind of question that can be asked with respect to the exam. So this makes probably a very useful session with respect to the upcoming sessions. Okay, so for supervised learning, for all the algorithms, it performs in a similar way, but unsupervised, there is no prediction, right? So this column is not there, so there is no pattern followed. It varies from algorithm to algorithm. But when it comes to supervised algorithms, the process is same, fixed. Okay, so I'll stop it here because I don't want to prolong it. Okay, probably we'll continue on Monday and we'll discuss the topics. The algorithms will start. Okay, uh, we'll go with hands-on as well. We'll do with two projects. Right. So, friends, it's time for your technical questions. Hope majority of you have understood the session well. Okay, and I see good feedback coming. Thank you for your feedback, friends. And if you feel these sessions are really impressive and amazing, just share across your multiple channels. Ask your friends, your colleagues, whomever it might be. Okay, so ask them to join on daily basis. And as discussed earlier, we are going to start a new program on Power BI on 17th of this month. I request everyone to share across multiple channels because Power BI is an emerging tool in the current market. Okay, in the current world, even if you learn Power BI, industry is paying you lakhs. Okay, to be honest, it is paying lakhs. So everything we are going to learn with respect to the sessions of Power BI from end to end. All the components of Power BI will be discussing. I want you guys to share across multiple channels, friends. Right, just hit on the like button, and if you have any kind of questions, technical questions, yes, feel free to ask the technical questions. So I don't know how many of you are from a similar background, but if you want to do any kind of machine learning projects or data science projects, even AI projects, in future we are going to even start those sessions. Taking projects, end-to-end projects will be discussed in these sessions. Okay, so we'll be notifying you. Our aim is to provide quality training. Every student should be every student have to learn these emerging technologies. Okay, so That is our aim, and I see majority of you are asking for what is it, feedback form. Yep, the form has been posted. You know, just go and submit your valuable feedback, friends. Any technical questions with respect to machine learning or artificial intelligence? Simple. That's what we have discussed. Machine learning is actually, it's actually subset of AI. AI is a vast uh, world. It's a world together. Under artificial intelligence, it is just a subset, and both of them are used for making decisions. To be honest, machine learning probably works more on structured data, and artificial intelligence, decisions can be made. The very widely used example is driverless car. Okay, so if you take a driverless car, who is actually driving the car? Who is taking the decision? So the car, the machine is taking the decision, right? So we train a machine, and we are actually giving an artificial intelligence to the machine. So that is nothing but mimicking intelligence, human intelligence to a machine is nothing but artificial intelligence, right? Yep. If no questions, thank you so much. We'll connect tomorrow, probably in the next session. Okay. Until then, take care. Right. Signing off.